Is this the best type of roller for this work? Is the soil in the correct moisture condition for compaction? Is the plant being operated in the most efficient way using the right number of passes? Is the right thickness of soil layer being employed? The answer to these questions is very important to the engineer because road construction usually involves a considerable volume of earthworks, the cost of which, in the case of the modern motorway, may amount to as much as 40% of the total expenditure. Since 1945, with these points in mind, the Road Research Laboratory has been carrying out a program of research in which studies have been made under controlled conditions of the performance of most types of compaction plant available to the engineer in the British Isles. Increasing the state of compaction of soil increases its strength and reduces the possibilities of settlement. If, therefore, economical designs of road embankments and pavements are to be obtained and subsequent maintenance reduced to a minimum, the soil in the embankments and subgrades must be brought to a satisfactory state of compaction during the construction work. In order to carry out the full-scale compaction tests under controlled conditions, a special building has been constructed at the laboratory. This building is 100 feet long, 90 feet wide, and contains 5 soil bays. Each bay is 35 feet long, 15 feet wide, and contains a 3-foot depth of test soil. The soils used are a heavy clay, sandy clay, gravel sand clay, and 2 types of sand. These are chosen as being representative of a wide range of British soils. To prepare the soils for the tests, special mixing machines have to be employed. The largest of these machines used at the laboratory is the 80 horsepower tractor with an agricultural type of rotavator mounted at the rear. The rotavator has a series of digging blades which are driven at a speed of about 120 revolutions per minute. With this machine, it is possible to break up and mix a depth of 12 inches of compacted soil. Besides having the normal range of speeds, this machine, with the special gearbox fitted, can travel at low forward speeds of a few feet a minute. This enables a very high degree of efficiency to be obtained in the pulverization and mixing of the soils. To start a full-scale compaction study, the layer of soil under test has to be broken up to form a loose tilth representing a completely uncompacted state. Any adjustment of moisture content that is required is effected by spraying water onto it, followed by further mixing. If a reduction in the moisture content is required, this is obtained by aerating with the rotavator. Samples are taken to determine that the soil is the correct moisture content for the test. The mixed soil of correct depth and moisture content is finally raked level. To illustrate the procedure used, let us look at the test work with a heavy pneumatic tired roller. This type of roller is widely used throughout the world for the compaction of large embankments. It can be ballasted to a total of 45 tons, which is carried on 4 heavy pneumatic tires. Inflation pressures of up to 150 pounds per square inch can be employed. The wheels are arranged in pairs on pivoted axles and are fitted with heavy-duty earth mover tires. The roller is being towed by an 80 horsepower track-laying tractor at a speed of 1.5 miles an hour.